Today we're going to talk about force. Now, when we're talking about force, we have multiple things we're going to have to cover, and we're going to get really intense later on. But we're just going to start off with just some basic forces. Two simple forces we want to start off with is we want to start off with like a contact force. So if I take something and I hit the object, okay, that's a contact force. There's going to be that physical contact. The other type of force would be a long-range force. These we don't understand quite as much because they're kind of abstract for our thinking. Gravity, magnetism, nuclear forces. Those are things we don't necessarily think about on an everyday basis, but they do exist.
Like when I captured the Millennium Falcon with my tractor beam.
Nerd alert!
That's right, Darth. Did you know that on the first Death Star, it was originally equipped with 768 tractor beam generators? What they did is they projected a magnetic field which helped draw that Millennium Falcon into the Death Star.
Now, the laws that we typically are going to deal with in this chapter are mostly Newton's laws. We're going to be dealing a lot with how Newton dealt with forces and what is going to go on with those. Now, we know from our middle school days that Newton had three laws of motion. And in those three laws, we start off with law number one, the law of inertia. Now, what is inertia?
Inertia is a property of matter.
Now, since inertia is a property of matter, what we're going to deal with is how that affects other matter or more matter. So what we're going to deal with is we deal with things that don't want to move, or once they get moving, they don't want to stop. And that's what Newton's first law is an object in motion will stay in motion, or it will stay at rest unless acted upon by an outside force. Okay, Newton's second law. Now this one we normally look at as just being an equation. This is the one that I just call the equation law. And the equation for Newton's second law is force equals mass times acceleration. So if I take a look at that, I can break it down into units. My unit for mass is going to be kilogram. As we said, that mass in SI units is going to be kilogram. Now, acceleration is going to be meters per second squared. Now this could be several different things. I could be just talking about accelerating, like I'm accelerating an object through a distance, or I could be accelerating by like free fall. So I could be dropping an object. So this could either be A, or occasionally you'll see it as G for gravity. We're dropping something. Okay. But we're just going to deal with it as A for now, so I'm going to get rid of that. Now when I put these units together, the equation equals force equals mass times acceleration, I'm left with a unit of kilogram meter per second squared. Okay, now that's not fun to write out. So what they did is they came up with a derived unit for that, and that is the Newton. Now, with the Newton, he's probably pretty honored that he got something named after him. Plus, it's a lot easier for us to write. When we're dealing with weight in this chapter, notice I said weight, not mass, we'll be dealing in newtons. Okay, Newton's third law. Newton's third law is going to be what I call the equal opposite law. Okay, so if something pushes on another object, that same force is going to be equal and opposite in that opposite direction. And in everyday life, we don't think of this a whole lot because normally we're dealing with things that have friction and we don't get that pushback near as much. But if we go into a frictionless arena, say let's go ice skating, that sounds like fun. So we go ice skating, we're out there on our little skates, and you give somebody a push. Then you start to notice it a lot more because you're pushing somebody at the same time that same force is coming back into you and you're going to get pushed backwards. So imagine being in space where there is no friction and you push off something, you're definitely going to feel the full effects of that. And that's how we end up with rocket thrusters that push things in space.
The rocket works by throwing stuff out the back, literally. It makes use of Newton's third law. For every action, there's an equal and opposite reaction. If the action is to toss something to the left, then the reaction will be that the tosser will be moved to the right. I'll demonstrate using this spring-driven rocket. This is the spring that's going to be compressed. This chunk of copper is the reaction mass that's going to be thrown away. And this thread right here that goes through the whole thing is what holds it all together. Okay, so let's hang it up as a pendulum and try it out. To cut the thread, I'll burn it. The spring will throw the chunk of copper to the left, while the rocket reacts by flying to the right.
Now this week is incredibly busy. You have 3 labs, one of which takes a long time. 2 of the other ones aren't too bad, but the WebAssign, that's going to add a lot of time. So in order for you to get finished a little bit sooner, I'm going to give you some incentive here. The first group that completes all of their labs and all of their WebAssigns will receive a late pass. Now this late pass is for use on any assignment, not just your WebAssign or whatever. You can use it on any assignment, don't care where you use it, what's going on with that. So just a little bonus to you, and we will see you later.